Sure.
So since I'm so terrified of messing up, I always wait to hear an echo. And for that duration, I'm just looking around the screen everywhere, just looking for a sign to see if I'm
Go ahead
live or
and
not.
check. I wanted to also have a feedback on another monitor, but I thought it might generate some echo, so I skipped that.
Awesome. I think I can see myself, and let me make sure if my audio is connected. I think we're live. That's perfect.
Awesome.
Awesome. I'll just get started. Let me share my screen real quick. And as a proof, I was still in the middle of researching about Darek's journey. So that's why you see this blog post open. Now I'm on the right screen. Hey, everybody. Thank you for joining us on a Friday evening. I'm super excited to be hosting another Chai Time live Kaggle Talk, this time with Darek Kleczek. I learned the Polish pronunciation of his name yesterday, so I hope I got that right. Darek, thank you so much for joining me today.
Thank you. It's an honor to be on your show, Sanyam.
I'm always inspired and always honored to be learning from my FASTA peers, if I may. Although I'm sorry to call you my peer. It's more that I'm a very junior person who's still starting to learn, but I'm super excited to learn about your journey.
I think when I started Fast AI, I might have started with your blog post on how to do it. So you might be the reason I'm actually here and talking to you. So it's this universe where all of the things are connected, apparently.
I'm sorry you found that blog post. I know there are better resources to get started. Awesome. I'll quickly introduce the session. Welcome everybody, and jump into the questions from there. So anyone who's joining us for the first time, this is the version 2.0 of the series I've been hosting called Chai Time Data Science. Today, Darek, who solo won the Chai Tamil and question answering competition, will be sharing his journey and his solution with us. I really emphasized on solo winning the competition because anyone who's ever participated in a Kaggle competition knows it's really hard to be up in the leaderboard. And especially when you're competing by yourself, finishing first is truly a dream to many Kagglers. So this is a live talk, and all of you are welcome to participate in the questions and answers. Let me post this link in the YouTube chat. And pin this comment. So if you head over to this link, anyone that is there in the chat, it should take you to our forums and you can ask your questions here. The reason for using the forums is I try to copy Jeremy Howard, both of Tariq and my guru's approach, where you can actually come back and see the questions and it's not like I'm talking to a disappearing window. So please consider asking questions here so that everyone who's watching later can also learn. With that, here's the agenda for today. I'll start by asking Darek about his journey. Then we'll try to understand the competition and then his solution walkthrough. I always act as the rubber duck or the junior engineer who's asking silly questions. So you can expect a lot of those. And of course, everyone is welcome to ask any questions. I wanted to point out Darek's Kaggle profile. He's currently ranked 28 in the worldwide ranking system on competitions. Competitions is one of the hardest categories, in my opinion, on Kaggle. And he's in the top 30 of the worldwide rankings amongst the best of the best Kagglers. So we all are in a treat to learn from him. He's a IT director of intelligent automation and the PNG group. And I would highly suggest that you can find him on Twitter, which you should, at DK21. So, Darek, I now want to start by asking about your journey. I always start around this question, but what inspired you to pick data science up? You were very far ahead in your career and you decided to switch directions. What led up to that direction, and why did you decide to do it?
Good question. I don't think that was a decision. I think it was more of a process. of falling in love with machine learning and with data science. Like many others, my first proper encounter with machine learning was the famous Andrew Ng's course on Coursera, the one with Octave. So at that point, I thought like this is really neat. Like I love this concept, but I cannot really do anything about it. Like it was in this strange language. Like I wasn't really able to do anything practical with it. But I thought it's interesting. And so at some point later on, when my daughter was born, I went on a paternity leave for a couple of months to spend time with her. And I also wanted to do something for myself during that time. And I thought maybe it's the time to actually get to practice machine learning and get to figure out how it all works. And I wanted to do something practical. So I wanted to prove my skills, and I decided I will build an application that will generate nursery rhymes for children, like children poems in Polish. And to do that, I did the deep learning specialization on Coursera, again by Andrew Ng. And that was the time where RNNs, recurrent neural networks, were really popular. There was this famous article by Andrej Karpathy about the power of RNN. So I experimented with that a little bit. I got my first, I created my first data set. I got the network to learn. I got the network to go really bad. And I thought, okay, this is probably because my learning rate is too high. And I thought, well, wow, I understand how this concept works, and I can practice it. And there are some outputs, like they look like poetry. They weren't super, like, so the RNNs didn't work so well when it comes to generating poetry. I did ship that up. I think it's important to ship the product that you plan to build. It had a much simpler Ngram language model behind it. It worked pretty well. I think it's still somewhere on a free Heroku server in the internet. But at that point, I thought, well, I can build something, and it's so much fun. So I consider this Coursera and Andrew Ng classes as my undergraduate degree. And my graduate degree is fast AI. So at some point, I might have stumbled on your article about how to do online courses and how to do or not to do fast AI. And I started following the course. I fell in love with the approach. I started following Jeremy's advice, and one of the pieces of the advice was to get on Kaggle and do Kaggle competitions. So that's how I came and started to do the competitions on the platform. I actually signed up a couple years earlier. So when I signed up, I don't remember when or why. I heard about Kaggle. I signed up. I picked a really dummy username. I didn't consider it seriously. But at that point, I didn't understand what Kaggle was about. So I had an account, but I didn't really follow anything there. But only after I did the fast AI lectures, I started to understand and try to participate in competitions. And the competition experience was actually super useful because at some point I got the confidence that, hey, these are real business problems, I can solve them. And at some point when I got the confidence that I can actually build solutions, I talked to my boss, hey, I want to do some of this stuff at work. And fortunately, it was around the time where we actually needed to use some of the skills in my work. So I also started practicing this at work. So it was a very long process and of falling in love with machine learning. And I don't think there was ever a decision to start doing it, to be honest.
That's really interesting. I'd love to dive into different details. Thanks for the shout out to this article I had written for the audience. It's called How Not to Do Fast AI. And in this, I talk about the struggle of understanding top-down learning. And I have this question for you. You've been in the industry for so long and you've worked across very senior positions. Was it natural to you, the top-down learning approach? You mentioned you shipped the nursery rhymes, even though it wasn't working effectively. To someone who's just started their journey, how can we really implement this mindset? Because it's always this scary feeling of sending out something that's incomplete and that terror that comes with it.
Yeah. Yeah, this is a good question. I'm thinking about, so when you're asking this question, I'm trying to figure out if I always follow this top-down approach. Definitely for me, like when I think I recognize like this concept of top-down learning when doing fast AI and listening to Jeremy talk about this HBR. I think it was Harvard research or a Harvard professor that talked about this top-down approach. Let me maybe use a different experience from my life other than the professional setting. So I've been practicing Kung Fu for I think 16 years now. It's a longer time than I work, so it's quite a while. What you do when you practice Kung Fu is you try to use, like, that there is a set of techniques that you're trying to learn, and all of these techniques have practical application. And if you just use them, kind of like try to practice them without understanding their applications, like it's not gonna work, because you will be just doing the movements without really understanding why you're doing this movement. So when you practice competitions, like, you also have people or the teacher, the master that shows you the technique, and you try to emulate, like you try to do the same stuff, and then you try to apply it in practice. So in Kung Fu, we had this exercises in pairs when, like, somebody tries to attack me and I try to defend myself, or we try to apply this technique. So I think this concept of application is super important, because without it, it's pure theory. And what I found myself is if I can use knowledge and build something, then I feel I'm making progress. If I just keep learning, and it sometimes it's superficial understanding. Like, I feel I'm making progress, but it's not tangible. So I think it always helps to apply the knowledge. And big thanks to Jeremy for, like, pointing out the research behind it and making it really straightforward.
I think, and again, sorry to compare myself with you, but I gave up. I was studying karate and I gave up around blue belt. I understand you're a black belt. And one of the things they really teach in karate or in any form of martial arts is so much more practice than theory. I think it was like 4 months of just doing the same step again, and like probably 1 or 2 sessions of theory throughout that event. So I really relate to that as well. So connecting that to Kaggle, how did you find your sifus on Kaggle? How did you find the people to follow, and how did you improve on Kaggle?
So definitely your show was one of the places to find all of the sifus. So during Chai competition, I think there were a couple of episodes that I listened a couple of times in a row just to figure out, what some of the grandmasters are doing, and try to emulate them. My journey on Kaggle has been evolving. Like, I don't have one way to approach competitions. Like, when I started, like, very transparently, the first competition where I scored a silver medal, I forked the public kernel. I made some modifications. I tried to understand what's going on, but I didn't really fully understand it. I just blended something and I submitted it, and I was shaken up into the silver zone. I didn't learn much. I got hooked for sure, but I didn't learn much in this competition. But still, it was an interesting experience on how to approach it. Then I tried different ways. I think I invested quite a bit of effort into the TensorFlow question answering. So there, I wasn't very proficient back then, but I tried to put a lot of effort into understanding the data and looking at the model predictions. I think I also learned it from your show about, becoming one with data and trying to really grasp it. So that was helpful. I think my big breakthrough was the tweet sentiment competition, and that one I actually ended up somewhere in the third hundred, somewhere down there. So I didn't get a good score, but that was the first competition where I started to actually implement some of my own ideas and read papers and try to implement stuff from papers. And at the very end, when I read the top solution, like the top solutions on the forum, I noticed that some of the winning solutions had similar ideas to what I was exploring, and that was a huge confidence boost. Like, okay, I can get good ideas. I can approach these competitions in the right way. It's now a matter of execution, right? So, and here again, this continuous improvement comes in from kung fu or karate. If you practice it, you know it. Like you try to, like every competition, you try to do it a bit better. There was a period where I did a bunch of competitions, and I tried an approach where I would take a good public notebook. I would try to rewrite it and try to understand what I'm doing as I rewrite it. So rather than forking, just write it, from scratch, but like really writing whatever was in the public notebook. And the idea, the concept I had was, first I would learn how to write my own kernel. And second, when I then read the winning solutions, then I will already have a stake in the game. I will understand what the competition is about, and I will be able to grasp some of these ideas. So I followed this for a couple of competitions, but then also, like, I'm not sure if this worked really well. It probably helped me, but it was not sustainable. And I think another breakthrough was the HPA competition. So this is where I decided to start super early, to write my own EDA kernel, to write my own baseline kernel. And when I did it, I really fell in love with the problem, with the data, like all of these microscopic images of human cells. Like, that was fascinating. The problem was really challenging, so it required some out-of-the-box thinking on how to attack it. HPA was my first team-up experience. So and I only had one team-up experience on Kaggle so far. So I'm still a noob when it comes to teaming. And that helped as well. Like, it helps to have someone to talk about, like, to discuss ideas and to brainstorm together. So my approach to Kaggle is definitely keeps evolving. I think Chai was yet another type of experience, and I'm pretty sure, like, the next couple of competitions, like, this approach will be changing as well. So I guess applying, like, what you need to be successful with machine learning is you need to run a lot of experiments and learn from these experiments and try to take these learnings and put them into the next experiment. And I think at the macro level, like, you can treat each competition as an experiment, like, try an approach, figure out how to approach it, and then see, like, have you learned something? Like, what was your success measure? Was it getting a medal? Was it learning something? And then try to improve from the next competition and kind of approach it from a bit different perspective. So I think experimenting with the competitions is also a good skill.
I want to really thank the NLP meetup I think this was from the Polish NLP meetup group. This is a screenshot from their video, and there you shared 3 different modes of doing Kaggle. This is the full mode, quick mode, and points mode. I think I'm still in the quick mode to some extent. I want to understand from you, as a FastAI student, you learn about certain things that work really well and have been designed for different lectures. And then there's this disconnect of how do you take that knowledge and apply it to Kaggle. So could you please help me understand that middle ground of struggle? How do you kept you? Maybe it was really easy for you, but for me it's really hard. How do I motivate myself and how do I improve there? Because I always find myself cheating and looking at public notebooks and not being able to design anything by myself.
Yeah, I think it's not easy. And I think what is important is getting comfortable with making mistakes, and ideally in public. So there was this, I think it was quite recent, there was G2Net competition, which was about signal processing. And I wanted to apply this approach where I try to build my own baseline or EDA very quickly to this competition. And I used my skills from FastAI. In FastAI, we didn't really dive too much into signal processing. So I think I just converted the signal into an image, and then I applied the CNN, and I made the predictions, and I published it. And I thought, okay, let me just do it. It's probably not the right approach, Well, it's not a big big cost to just try and fail. And what I learned later is, okay, I took a step back and tried to understand how to do this properly. And you have all of these concepts like Fourier transforms. And I still not sure if I really understand like what this all means. But I think getting comfortable with trying things and making mistakes is helpful. Like, and then if you really spend a lot of time, trying to understand the concepts, like I think there are some fast AI lectures that I listened like maybe 5 to 10 times. So like some of these concepts, like they keep coming back to you. Think Fast AI book is also a great resource. It definitely helped me a lot in the HPA competition. Like there is this chapter on how CNNs work. And translating this knowledge about how CNNs work to a specific problem, like at some point you get this insight, like, well, maybe I can apply this concept that I remember now to this type of problem, and you try it, and sometimes it works. Like maybe one in 100 times it works. Like 99 out of 100 it does not work, but that one time is worth it. It's worth the 99 tries.
And sorry to ask so many stupid questions, but I'm just trying to understand it, maybe for my own struggles. But when you're trying to find these ideas to implement, it's again this challenge of first understanding the paper, then being able to implement them, and doing it for so many different ideas across competition. Is there any secret to getting better at it, to being able to understand papers and implement them fast enough?
There are a couple of secrets. One is searching through GitHub. Another one is searching through Stack Overflow. I don't consider myself a very good programmer. Like I did some programming when I was studying many years ago. Then for many years I did not do any programming. And then I picked up Python when I did all of this online courses in machine learning. So I'm not super good programmer. I don't think I'm really that good in math. Like again, I did something back in university, then I did some math on Coursera, so I more or less understand it. But I still remember this famous example from Jeremy about, I think, Adam optimizer. Like there's this number of math equations, but when you look at what it actually does, it's just a couple of lines of code, or maybe just one line of code. So what I did, like for Chai, there are a couple of ideas that I tried. And the idea was either coming from a paper or from a previous competition. I think there were a bunch of interesting insights from the Tweet sentiment competition about different loss functions and different types of model architectures. And I tried to implement some of those. Normally I try to time box it. So let's say I set myself a time for one day for an experiment, and I try to do as much as I can and test it. And if it works, then great, and I spend more time and try to improve it. If it doesn't work, then it depends. Like in most of the cases, I will just drop on and move to another idea. Like sometimes if I really feel like, well, this is exciting, I would put more effort into it. But I'm pretty sure one of the reasons that some of my experiments didn't work out is because I didn't properly implement them. Maybe I made some errors there, but I think it's still okay. Being okay with mistakes is an important skill.
That's helpful to know. I'll use this answer of yours of talking about Chai competition to transitioning to talking about the competition now. As a reminder to the audience, please keep the questions coming, and I'll keep asking them during the relevant portions. We'll definitely try to go through all of them. And as a reminder, here's the link to find our forums. So now moving on to the competition, it's called Chai Hindi and Tamil question and answering. So in this section, what I'll try to do is I'll try to understand and explain the problem. And Darek, please interrupt me and correct me anywhere if I'm wrong. So as I understood, the challenge here was there are two very prominent languages in India. And there's this thing we say about India: if you travel 50 kilometers in any direction, the local language, local food, and local culture changes so much. So we do have a lot of languages, but Hindi is the most spoken out of them, and Tamil is also one of the most spoken. I've lived in Tamil Nadu for a long time, and I think it's a really difficult language. It was for me to learn and speak. So I think it's a challenge in itself. And here, Google Research is trying to create this task where you can understand and answer questions in both of the languages. So that broadly was the goal of this competition, to try and be able to interpret this. And this is again one of the underrated problems in NLP, because these are local languages and most of the data on the internet is just in English. So far, have I got the context correct?
Yeah, no, definitely, and you definitely know much more about Indian languages than I do. I think one important point is the task itself here is a pretty straightforward task. Like it's question answering, where you have some context. The context is usually a Wikipedia article. Then you have a question, and you need to find a fragment of that context that answers the question. So the challenge is the task is pretty straightforward. The challenge here is the fact that well, this is not in English, and obviously most of the models that we have available are in English, and specifically here the fact that the training set is very small and noisy. Like that was one of the key challenges in this competition.
Absolutely. And again, just emphasizing on the fact most of the pre-trained models just exist around English, and again, it's difficult or an interesting challenge just to be able to understand this. So continuing further, let's look at the data. As Darek mentioned, it was quite a small data set. I think there were about 700 examples in the training set for one language and 300 for another language, which is very, very few compared to what other models have been trained on. Inside the dataset, you could find the context. So that tells you the text, if it's in Hindi or Tamil, that those are the two languages. You can see if the question is in Hindi or Tamil and what is the answer there and where does the answer start. I'll probably suggest you to check out a kernel by Darek, where he has simply explained how to go about this approach. And there he explains if you have to simply get one answer, for example, when did something happen? And inside of a long answer of text, it says 42. You just need to be able to create a model where you can pick that context and share the answer. I think I've mentioned all of the details. I also have your EDA kernel open, but that also mentions the same thing. And as I said earlier, Hindi has about 750 examples. Tamil has about 370 examples in the training data set. And the metric here.
I didn't do too much work on this EDA. I started this EDA. I thought I will dive into the data, but then I noticed it's like a very straightforward question answering. So I moved on to the baseline very quickly. I think I didn't do a good job on the EDA here, and there are some folks on the forums that have spent much more time and gotten some good insights looking at the data.
Actually followed the lazy approach where I sorted by votes for EDA kernel and found your kernel. That's how I landed on your kernel. But again, quickly pointing the metric out to the audience, it's called the Jaccard score. If you're new to NLP, you can simply go through the forums and understand it. It's explained in the evaluation sector, but it basically is the intersection over union metric. So I think that was what I wanted to explain in the context of the problem statement. And now I would love to understand, how did you approach the problem and about your solution?
Sure. Let me share my screen. Let me know if you can.
I can see the strategy slide.
Yeah, okay. Let's start with the first look. So I think we covered some of these points already. So the fact that we have a small and noisy training set, that was one of the key features of this competition. So you need to think, like, first you need, like, if you have this type of data set, I guess the follow-up question is, what about the test set? Because it's okay if your training set is noisy, but if your test set is noisy, then it becomes a lottery competition where you can play like you playing lottery. The answer from the host was that actually the test set was annotated in a different way from training. So training set has one-way annotations, which means like each question and context, there was one person highlighting the answer. But for the test set, there were 3 people highlighting the answer for a given question and context. So that means that even if one person made a mistake, like there were 2 others with as a backup. So the idea here is that test set should be more robust than the training set. And that means also that if you try to do CV on cross-validation on your training set, it's very likely to be very noisy because you have very little data and the data is noisy. But if you look at public leaderboards, it should be more robust, and it should, like, public leaderboard and the private leaderboard should come from the same distribution because they were annotated in the same way. So that was a big leap of faith. Okay, can I trust the public leaderboard? If I can, then that means that I can participate and put all of this effort into the experiment. If that is not a good measure of performance, then that means like you can do this hundreds of experiments and spend many hours, but at the end you will be shaken down significantly. So that was a bit of a leap of faith, but I thought, like, my intuition was like, yes, I should be able to trust the public leaderboard, and that's how I designed all of my experiments. I used only public leaderboard for validation. I did not look at my local CV at all.
I'm sorry to interrupt. When you say noisy training set, do you mean the labels were sometimes incorrect, or what does noisy here refer to?
Yeah. The labels have been sometimes incorrect, or there were many potential answers that you could pick. I think there was one feature. Well, there was one feature that some teams exploited. At the end, I did not exploit that feature, where the annotators, they picked the answer from the context, but then they, like, sometimes somewhere in this data processing step, the place from where they picked the answer was dropped, like it was not there in the data. So what the host did is they automatically found like the first string in the context that matched the answer, and they said this is the location of the answer. But in some of the contexts, an answer might have appeared like 10 or 15 times. So maybe the fact that a certain word appears at the very beginning of the text does not mean that it's the place where you should look for the answer. Maybe the answer should be somewhere later on in that context. So some of the teams have done a correction there and picked the proper location of the answer in the training set. I actually missed that opportunity. So kudos to the folks that actually did that correction. The obvious idea, given this noisy training set, was, well, we should use external data, and that was my initial thinking. Like, if somebody spends time labeling data, taking, like, for example, you can consider this as a leisure exercise. Like, you read a Wikipedia article, you write questions, you take the answers, and then if you really put effort into that, you could build a pretty sizable data set and use it for training and hopefully getting a good score. I think that was the idea from the host as well, because they wanted to use it as a chance to collect data sets in those languages that can be used by the community. I think at the end, actually, people did not do that. It seems like this was a much harder work than just experimenting with the models. But I guess one of the insights was we have data. We don't have much data for Tamil, actually. There was some data for Hindi, some existing data sets from Hindi that I think everyone used. These were translated data sets, but they were manually translated, so the quality should be good. And but there was also data in similar languages. So there is this big data set that is called Chaii that contains question answering data in various languages, including Bengali and Telugu. And from what I Googled, I think Bengali should be from the same language family as Hindi, and Telugu should be from the same language family as Tamil. So using these languages along with English, like that was the external data that was really, really helpful in this competition. So it made up for the fact that we have little Tamil and Hindi data. And the other thing that was pretty that was at least my insight at the beginning of the competition, because we have this noisy and small training set. We should try to have a diverse ensemble, because that should kind of like prevent the risk of overfitting in one or the other direction, and it should help with having a good score on the private leaderboard. It turned out in the end that if somebody bets properly, and by betting properly I mean betting on Muriel backbone, which was kind of like an Indic language BERT model, then that might have been a very good choice. So Muriel turned out to be good, but it was very hard to know it in advance. So I think diverse ensemble was very helpful here as well. So these were like early insights from the competition. So my strategy on how to approach it was, so first I started pretty early, then I took a break. Like I think this was like a 3-month competition, and I took a break for like maybe two months. And then when I joined in the last, I think more or less month of the competition, then I said I'm taking it really seriously, and I want to put effort and try to do as good as I can, as well as I can. And I try to put the most effort into training good single models. My idea was that, and I'll talk about it in a moment, like there was this, like most people use this 2-stage approach, where there was a stage of training on, for example, on squats, and then training on the Chaii data. So I would spend some time training this first level models and the second level models, and then testing different backbones. There were a couple of backbones that were available. I had this idea that I had in my head, and you asked about it, like how do you take fast AI ideas and implement them? So the idea of using this image-like augmentations, I tried it already a couple of times in different competitions before. Sometimes it works okay, but it never works super well. So I thought, okay, maybe this time it will work. So I'm gonna try it again. Try to study the previous competitions. TensorFlow, QA, and Twit Sentiment were the most similar ones. Try to look at papers for what are the SOTA results and approaches. And what I found super useful was actually checking, like we had different backbones here, different models like XLM Roberta, Muriel, Rembert. And each of these models requires a bit different fine-tuning protocol. And checking in the papers, like what is the way that the authors of this model fine-tuned them, it was super helpful, because it speeded up the, like you didn't need so many experiments with training these models if you just followed the recipes from the papers. And then I think in the last couple of days, that was the time that I had for ensembling. I think this is the approach like that I also got from one of your interviews with Dieter, like spent a lot of time, trying to very quickly experiment with simple models, and then at the end just try to do ensemble. Okay, so moving on. This was the typical approach. There is this there was a very popular public notebook that used this approach that got a very good score on the public leaderboard, I think by Koshal. And the approach was like, first you take a model that, like, we used pre-trained models here. The models were pre-trained on mask language modeling, and we used multilingual models. There were some, I think, single language models. I think there was one team that actually trained, like transferred Roberta into Hindi and Tamil. I thought that approach, well, most of the teams use multi-language models, and I thought that was also helpful because then you can use all of this data that you have in other languages for training. So most of the teams use these multilingual models. There was a very early discovery by Nicholas Broad that he shared on the forum, that if you take XLM Roberta that was pre-trained on English Squad by a company called DeepSets, and a huge shout out to DeepSets. They're doing a lot of good work in question answering and offering some frameworks for that. So if you're into question answering, check out DeepSets. So they trained this model, this multilingual XLM Roberta model on English Squad, and just taking that model and applying it in this competition, I think it's exceeded the score of the baseline preferred by the host. So that showed the power of using model trained on a different language and applying it to Hindi and Tamil. But then if you took this model and you trained it on Chai and this additional data that we had, so we had some subsets of MLQA and XSquad, which was a question answering data set in Hindi. And then some people also translated squad into English or into Hindi or Tamil. So if you fine tune that model on those data sets, then that led to really good results on the public leaderboard. Now, there were two opportunities with this approach that I recognize a bit later, but that ultimately helped me. So the first opportunity is, if you follow this approach, then between these two stages, you reset your optimizer state and the learning rate schedule. And the way I'm thinking about this optimizer state and schedule, like if you have all of this big lost landscape, and then you have a ball that is rolling down those hills of the lost landscape, and it has certain speed and momentum, and it's trying to find your loss. But if you just reset it and you put it into a random, well, like whatever it ended up, and then you try to train again from scratch, then you're losing all of that momentum that you gathered in the early phase of your training. So maybe you can do better by combining these stages. And the second thing that was an opportunity here is this fine-tuning data set is pretty small. And what most people did is they prepare the data. So they prepare the features by sliding a window over the context and then tokenizing that and connecting that with these questions. So there is a fixed training set, and then you train it for a couple of epochs, and every epoch, like you just shuffle the data, but the data is always the same. So there is a risk of overfitting. So there are a couple of places where we can do better with this approach. And one of the insights that I got, it was from an experiment where I moved and I still try to follow this two-stage approach, but I thought like maybe I can take this Hindi data into the pre-training stage along with English Squad, and maybe I can also use Chaii for pre-training. So this is where we had this English.
Sorry, I wanted to interrupt you and confirm. So when you take a model for the first phase here, is it already like, does it have weights that have been trained on an English data set, or are you just training them for the first time on these data sets?
Yeah, good question. So this is already like a pre-trained model, and an XLM Roberta would be pre-trained on masked language modeling. So you have this task where you just trying to predict masked words in a text. And the multilingual Roberta would be pre-trained on many languages. So it would already be pre-trained with masked language modeling on Hindi, Tamil, English, Bengali, Telugu, all of those languages. But it will not be pre-trained specifically on QA task. So I think this pre-training and fine-tuning, I'm probably using the terms in the wrong way. But it's kind of like a two-stage approach where you train the model on some data first, and then you take that checkpoint and you train it again on another set of data. So in this
again, sorry for another silly question, but when you take this XLM Roberta backbone, is this a Q&A model already, or did you modify the heads to make it understand and interpret questions and answers?
Yeah. So good question. And Hugging Face fortunately makes it super easy. There is a class that is called Auto Model for question answering. where you say, I want an auto model for question answering from pre-trained XLM Roberta, and it takes this pre-trained backbone and it puts a very simple head on top of it, where you're trying to predict the start logits and the end logits of the answer. So you're looking into the context and you're trying to predict like what is the start of the answer and what's the end of the answer in that context. So it's a very standard architecture. It's like it's an auto kind of model in Hugging Face. So this head specifically is like you started from scratch, but all of the backbone, the model is pre-trained on mask language modeling.
Okay, understood. Thank you.
So you can put all of this different data into the pre-training stage, except for Chaii, right? So you can do this first stage of training on tidy, different languages from the tidy data sets. You can put English there, Hindi, MRQA, and XQuad, and then like you train this model. So you will, by this, like after you finish this phase one, you have a pretty good question answering model, but not specifically trained on Tamil or Hindi, except for maybe this translated data set. So the idea was then, okay, so let's take that model and fine tune it on Chaii. And the insight here was, I did this for a couple of experiments, and the performance of this phase one model was actually better than the performance of this phase two model, which included a fine tuning. So there was like either this data was actually so much noisy that it resulted in bad signal for the model, or maybe like this data was actually so good that after restarting like all of this optimizer state and all of that stuff, like I like my model went into the wrong direction, right? So looking at this, I thought, okay, maybe I skip this two-phase approach and I will just do one phase. So this is the single stage approach where I don't split my training into two phases. I just have one single stage training where I preserve the optimizer state, the learning rate schedule, but I still want to control the order into how I put different data into the model. So I still want to start like put squat into the beginning of the training. And the idea is squat is a pretty simple data set. It's pretty straightforward. So it should be easy for the model to start learning question answering on squat and then move to more difficult tasks, kind of as it gets knowledge during the training. So I wanted to control this order. So this is what I call data recipe, where rather than taking some data and then putting this into a data set and then putting this into a training group. And what typically happens in a training group is you shuffle the data, so it comes in a random order, and then you train it for X number of epochs. So I thought I want to train for one epoch, but I want to be very deliberate when I put what type of data into the training.
There's a question from the audience, and this is by Mani Sivanesan. I'm sure you would know him through the FastAI community. Thanks for the question. Yeah. So he asked, what was the tokenization approach in the earlier two-stage approach and in this approach as well? Did you take a special tokenization approach or?
Mm-hmm. Good question. So the tokenization approach was the same. There was and I actually have a notebook where I will show some of this stuff in code in a moment. The tokenization worked in the same way. What I actually try to change here is the augmentation, and I changed augmentation by running the same tokenizer on the same data a couple of times to get different windows into my text. And hopefully I will explain this in a moment. But yeah, it may be Mani if you can make the question a bit more specific, then I can answer it. But generally, the tokenization approach was the same in both of these approaches. So that element did not change.
Sorry, you were talking about the data recipes.
Yeah. So I put the data in a specific order. That's trying to figure out how to do that was actually took me some time, but again, Hugging Face like him with a really nice. They have this very nice transformers library, but they also have a very awesome datasets library, and this datasets library was super useful here. So what I do is I take this tidy data, I add squats, I add this, and then I add both Hindi and Chai in the very beginning of my training. Then I take the same data, I take out squats because squat is easy. So I just wanted to use it only in the beginning of the training. And I replace squat with natural questions. And the idea is that natural questions should be much more difficult. But natural questions is actually very different from Chai because like Chai is questions asked by annotators. Natural questions like has all of the random questions from the internet. So I only took a subset of natural questions and I tried to build a model that will predict which of the natural questions are similar to tidy or Chai and only take those similar questions there. So I put natural questions into the next stage, and then I finish it off with just Chai data in some experiments. Later on, I figured that this finishing off with Chai is not necessarily super helpful. But then there is still some data that is repeated here. So I put tidy in the beginning, then I put tidy into the next stage, and then I have Chai here, and I have Chai a bit later. So there is this risk that my model will see the same example a couple of times. So in order to prevent that, I use these augmentation techniques. So I tried three types of augmentation. The first one is random cropping. The second one is progressive resizing, and the third one is cutout or random masking. And they all come from image augmentations. And that's an inspiration from FastAI. I think in one of the lectures when Jeremy talked about his work on ULM fit and how he took this concept of pre-training a model on ImageNet and applied it to text with NLP, he mentioned that's what I remember. There are many other concepts from computer vision that you can apply to NLP. So I thought maybe augmentations could be the thing. And the way so the way I'm thinking about these augmentations and how to translate them. So random crops, like on images, it's pretty straightforward. You just take a crop from an image. And on text, it's also pretty straightforward. So you in question answering, you have this long context document, and then somewhere in the document you have the answer. And then typically you go with a sliding window through that text with a sliding window of a certain size, like 256 tokens, for example, with a certain stride. And then it means that maybe you pick up 2 or 3 examples with this answer, but these examples will always be the same. But rather than doing that, you can like take every time a different crop from that text. So I think doing this already adds some good diversity to your model. So you never have two similar, like the same example twice in your data. Always you try to put some variation there. Another augmentation that we have in computer vision is cutout, where you just introduce some noise to your data by cutting out pieces of your image, and you can then do the same with text by randomly masking some words. And this, I think this was also used in Twitch Sentiment by Chris Diot. So big shout out. I also learned a lot from Chris, including the interviews that you've done, Sanyam. So thanks for those. And then there is this FastAI idea of progressive resizing, where you start training on small images, and then you increase the image size as you keep training. And you can do the same with text, because you can start training, for example, with sequence leg of 256 tokens, and then you can increase it to 384, and then you can increase it to, for example, 512. And I think somebody pointed out on Twitter that this was actually used when pre-training BERT. So BERT was pre-trained, I think, on 128 tokens, and then at the end with 512. So it's not entirely new on NLP. I think the nice trick is doing this like without actually resetting the state of your optimizer. You just sequentially, like as you go on with training, you increase the length of your sequences. So using these three augmentation techniques means that we have a lot of data because we took all of this external data. And even when we repeat examples from the same data set, we use a different variation of those examples every time. So it introduces variety to the model and hopefully it helps with learning.
This was so incredible. I was also telling you right before our interview as well. I was really mind blown by how you decided to take this approach and compare the image augmentations with NLP augmentations. People in the chat are also absolutely appreciating how creative this approach was.
That's awesome. So one of the ideas now, and I think I published it on both the FastAI and the Hugging Face Discord servers, is to do some ablation studies, because like sometimes you come up with these ideas and you really want them to work. I think it's also a feature of research, right? You have this idea and you really want to make it work. So I think I've done so many experiments with these augmentations that at the end I'm not really sure if they were so helpful. Maybe if you don't do them, like the model will still train pretty well. But it's fun to try them out. I think now is the phase where I'd like to do some ablation study and see like which of them are actually helpful. And it might depend also on the size of the data that you have and the type of the problem. But it's always fun to try something different and see if it's gonna help. It makes the competition more interesting. So I don't want to kind of do slides only. So I also prepared a demo training notebook that is now, I just published it today on Kaggle. So if you want to see how these ideas are implemented in code, then in this notebook, I implemented all of these ideas. This notebook so I trained a single fold in this notebook. I checked how it performed. It would end up in the gold range on the private leaderboard. So I think it proves that this concepts work. It's a bit different from the scores that I got from my home machine because Kaggle has a bit different environment, but it works pretty well. So I will just point out, some other insights. It seems like Hugging Face has a question answering trainer. I'm not sure if it's part of the library, but it's in the sample script. And by using this question answering trainer, you have the training loop with the squat metrics implemented. So that's I think most of the people in the forums, they looked at the validation loss, but validation loss is not always correlating well with your final performance metrics. So I actually did not implement Jacquard's metric, but looking at the squat metrics like exact match and F1 score, I think it was correlating pretty well. So using this question answering trainer from Hugging Face was super helpful. There is a lot of code here that I did not write. So it's a copy paste from Hugging Face scripts. A lot of this code is actually written by Sylvain Kugler. So again, another shout out to the FastAI to the FastAI community. It was super helpful. So a lot of the code I just directly reapplied from Hugging Face scripts. There is one modification here. So I overload this trainer and I make one change where I change the sampler into sequential sampler. And if you remember what I tried to do here with the data recipe, I want to control the order in which I put data into the model. So if I use like the default random sampler, like it will just shuffle all of the data as it comes into the training loop. I don't want that. I want to be very specific about it. So I change my sampler to a sequential sampler. So that's one important modification. What else? All of this preparing features and QA post-processing is coming straight from the Hugging Face demo question answering script. So I have not done any modifications here, so I won't go through it. I want to move into, this is one I think that was helpful. So a lot of these examples that we use, specifically from tidy natural questions, they have very long context. And if you have very long context, then that means that you have a lot of negative examples. So like if you go with a sliding window through that context, then there will be many windows where there is a question and you don't have the answer to your question in that fragment. And if you just have too many of these negative examples, then the model does not like really learn what you want it to learn. So removing some of these negative samples is helpful. So this negative sampling was useful. I think this post-processing is coming from Abhishek. So again, big shout out to Abhishek Thakur. I also learned a lot from him and his channel on YouTube. Especially when doing tweet sentiment, I would try to code along with Abhishek and learn how he's doing the like he's solving NLP problems. So that was super helpful. This helped with XLM Roberta and Rembert, because their tokenizers were sometimes concatenated, like they were not splitting the punctuation marks from subwords, and that was necessary for matching the answer with the labels. So it was helpful for those models. It wasn't necessary for Muriel, which is the Indic languages birds, and Muriel was the strongest backbone in this competition. So data recipes, progressive resizing, and random cropping, it's all implemented in this single function. There's a lot of pandas boilerplate here, where I take all of the different data sets and then I prepaint features. So going back to the questions from Mani, I use this tokenization like in the same, like this is my tokenization function, right? Prepare train feature. So it does not differ. It does not differ between the one stage or two stage approach. What I do change is, if you like this is Chai data set, and I apply this tokenization 3 times. So the first time I do it with the sequence leg of 256 and stride of 128. Second time I use a different sequence leg. So this is progressive resizing, and I use a different stride, which helps me with this random cropping. So every time doing variation on the stride, that means that you have different examples coming into your model every time. And then if you mix that with this random negative sampling, that way you introduce the variety. And yeah, there is some negative sampling here as well. There's a lot of kind of code here. And then this is the key. So I take all of these data sets that I tokenized here, I concatenate them and shuffle them, and I put here specifically epoch 1 and epoch 2. So in epoch 1, I do tidy and squats and this Hindi MLQA and X squat and Chai, and I shuffle it together. Then in epoch 2, I put again tidy, but now this is the different sequence length. So tidy, this time I take natural questions and again Hindi and again Chai, and again I shuffle this, and then I put I concatenate epoch 1 and epoch 2, but this time I don't shuffle because I want the first epoch to come before the second one, and that becomes my training data set. So this is where this is the data recipe. It's pretty boring. There is nothing super advanced here, but I did a lot of experiments with different recipes. In Tidy, we have 8 different languages, I think. So I tried to check is Japanese language helping with this challenge? Is Russian language helping with this challenge? So I tried to use different data and kind of different way of ordering that data. So it felt like I'm cooking, right, and trying to prepare some dishes and experimenting with different ingredients and proportions of those ingredients. So and maybe this is there is this data-centric AI movement, right? That I think Andrew Yang is spearheading, and for me this was this data-centric approach. You try to see how to use different data. The model is fixed, right? But you try to put a lot of variation in your data and see which one works best.
Did you consider back translation here? So where you take one language, translate it to another, translate it back? Or...
Yeah, I was thinking about it. I was specifically thinking about it for the questions. Well, so actually, let me take it back. So one thing that was actually a lot of people experimented with, and I did some experiments with it, is not back translating, but just translating data. So we had this English squads. We have a lot of English data sets, and some people translated that like through Google Translate APIs automatically into like Tamil and Hindi, and that already gave you a significantly more data. The problem with this automated translation is that well, it's not always helpful, right? Sometimes it adds some artifacts that may be actually preventing your model from learning. So I did some experiments with translated data, but at the end it wasn't very helpful, so I did not use it. I was thinking about back translating, but only back translating the questions, because the context was like when you had a question that was like maybe 10 words and then a context of like 4,000 words, then you could have a lot of variety in the context just by taking different crops from that context and applying these augmentations like masking. Like you already had a lot of variation in the context. So I didn't think that back translating that would help. I was thinking about back translating the question, because question was pretty short and you wanted to have some variation there. So that was on my bucket list, but I didn't actually get to do it. So it might be an interesting experiment to check.
Thanks for the answer.
Cool. So one more thing that we have here is cutouts. So random masking, and you asked about this question, like how to implement those ideas. So the way I implemented this, again, I'm not a super good coder, but I'm trying to connect the dots. So cutout is really random masking, right? You try to replace some tokens with a random mask. And you also need random masking for mask language modeling, right? So in mask language modeling, you also like apply this mask and then you try to predict what is the word behind that mask. So Hugging Face has a function that is called data collator for mask language modeling, where they implemented this mask, this random masking. So what I do here is I look up that random data collator for mask language modeling, and I try to understand how it works. And most of my code is actually a copy paste with some changes, right? Because I don't need the labels. I'm not trying to predict the value of the mask here, but it's not like I come up with all of this code by myself. Sometimes it's just figuring out where to look for a good example and trying to adjust it. Good. And now the training is super simple. So again, I'm using the Hugging Face trainer. I usually use the hyperparameters from the paper. So this is using the Muriel backbone. Muriel is actually trained with fine-tuned with a pretty high learning rate. So in the paper, they mentioned 3 e to minus 5. And I think I trained most of my Muriel backbones with 3 e to minus 5. At some point, I made it a bit smaller because sometimes this training would collapse. But then most of the other hyperparameters I did not change. And then if you use this question answering trainer from Hugging Face, then you can very nicely see how your training loss is going down. Actually, because of the data recipe, at the very beginning we put some of the simple data like squat, so the loss is getting pretty low here. But then you're adding some more complex data, and then you're increasing your sequence length, so your training loss is actually going up. But if you look at your validation, then the validation actually keeps going up. So it's a good sign. And these are the squat measures. For some reason, I wasn't able to get validation loss to work with this trainer, but I think these measures were more meaningful than validation loss. So I was okay with this trade-off. Yeah, and then you can look at your final results, and you can calculate the Jacquard score for the validation. So if you look at the inference for this notebook, it would score a gold medal in the Chai competition, and it runs in, I think, on Kaggle kernel. It completed in around 8 hours.
I just wanted to say how beautiful the solution was, especially the image augmentation part and everything else. Also, you try to understand winning solutions, they're complex, but just having this experience of understanding them and understanding what goes into a gold medal, especially with something this creative, it's such an incredible experience always. just wanted to say that instantly.
Yeah, appreciate it. I still have a couple of ideas that didn't work out. So if you want, I can quickly go through them before we move to questions. So yeah, this is my final ensemble. So just want to quickly highlight that. So at the end, I use three backbones. And the reason I use three is because I missed one. There was apparently an info XLM model that was also a strong multilingual backbone, but somehow like it was not mentioned on the forums, and I didn't find out about it. So I used the three that were discussed on the forums. Muriel is a pretty, well, like both Muriel and Rembert are pretty new, and Muriel is the strongest backbone. So it has the BERT architecture, BERT large, and it was pre-trained on Indic languages specifically, and it proved to work super well here. A single, like my best single model. So this was my best single model on the public leaderboard. It's called 802, and it's called 783 on the private. So my best single model would still get the first place in the competition. So I was pretty wow about that. The sad thing about this single model is I think I did not use some of the augmentation techniques in this training run. So this is why this ablation study might be important. It definitely used the data recipe, so that was helpful. But I think some of this augmentation, they helped at the end with the ensembles and with adding more diversity into the total ensemble. So the standard way of approaching ensembling, like with the same backbone, is you just blend it, right? So you average the outputs of the model. So the blend of the three Muriel models was 808 on public, and it was 787, which is the same as my final kind of ensemble score. So Muriel was definitely the strongest performer here. And I think one team that just used Muriel, it was shaken up from somewhat like below into the third place. So another evidence that Muriel was a super strong model here. And then I had a blend of 5 Rembert models and 5 XLM Roberta models. And then after blending within each of the backbone, I did voting. So I had three outputs, so three like sets of words, and then I did majority voting at word level. So if 2 out of the 3 blends told me that a certain word should be in my final prediction, then I would keep that word. If that did not happen, then I would take that word out. So the final score was 8. So it was second on public leaderboard, but when I saw, I was waiting for the final leaderboard to be reviewed, and when I saw its first place, I was like in shock. I was in total shock. I did not believe what was happening. But
I remember talking to you then, and I was very pleasantly happy, and you were still, you said, shocked by the result.
Yeah, it was a shock. I did not anticipate it. Yeah, so that was this is the architecture of the final ensemble, and things that didn't work. So I tried some architecture modifications and loss function modifications, and at first I said like these things didn't work, but I think I should say I didn't make them work, because the reason there might be many reasons why they didn't work. Either I made some implementation error, or maybe I didn't put enough time into testing. Maybe there was like if you change the architecture, maybe you should also test like have a different set of hyperparameters, right? So I think maybe these modifications might help, given more time and effort. At the end, I try to time box each experiment to a certain duration, so that I can keep moving and experiment with different things. So I tried using a different head architecture. There is this XLNet architecture where you first try to predict the start tokens, and then take that into account where you predict the end tokens or the end logits. So that didn't work for me. There is a way to do a specific loss function for that should correlate better with Jacquard score. So I tried this as well. I think this one I'm pretty sure I didn't implement this properly, because I'm not super good with math, but at least I tried. And then I was super bullish about MT5. So this is another architecture which is sequence to sequence. And the reason I was bullish is first, like MT5, the largest version of MT5 is kind of like the state of the art for like small data regimes. like what we have here. And I also participated in a Polish competition, Polish NLP competition that was about question answering. And I was knocked out by another person that used the MT5 model. And I thought, wow,
interesting.
Maybe I should try this one. But well, in that competition, we didn't do, it wasn't a code competition. So the person like that and Mateusz, so shout out to you, Mateusz. Like he had access to a TPU and he used the largest MT5 model. And that was a big contributor to success. I don't think that the largest model can be done in a Kaggle notebook. At least I wasn't able to do it. So, and the one that we were able to fit into the notebook, like it didn't work so well. I tried to do some label error corrections, but without understanding the language, correcting the labels is a pretty risky thing to do. So I tried to do it with Google Translate. So I ran like an early version of my model. Whenever the model disagreed with the labels, I try to translate it and figure out, okay, is my model better or is the label better? And I try to choose based on whatever Google was telling me. So I tried this, it didn't help, but maybe I didn't put enough effort into that. There was a way to improve the score with tokenization because of the fact that this tokens and the punctuation marks were sometimes connected. So if you can split that, then that should help the model. I think that's one of the reasons Muriel was so strong, but I wasn't able to make it work. And then I did some post-processing, which actually helped me on public leaderboard. But when I looked at this, my models with and without post-processing, it improved on the public leaderboard, but it was actually a worse score on private. So that was actually where public leaderboard was not that helpful. So yeah, so this is so I think these are the highlights. So I'm happy to take any questions.
Before we dive into the community ones, if you could please go back to the previous slide. I was really curious how are you tracking these experiments, and what process were you using just to keep on top of all experiments?
Yeah. So this is one of the areas where I know I have a big opportunity to improve. So in this competition I used Google Sheets, right? So I try to take notes in a Google Sheet and just keep notes of what I'm doing and what's the score. I remember your interview with I think Dieter and Philip. So one of the competitions where they went really. They came up with this approach where they experiment, like they had an experiment tracker, yes. And they used GitHub and they used and I was so amazed by this approach. I thought I want to do it that way, but in this competition I don't think I had enough time to you really need to learn how to do it properly to get the benefit out of it. So I'm still learning, and I think that might be one of the next competitions where I try to get better at tracking my experiments.
Thanks for that answer. If you could please stop sharing so that I may share the forums.
Sure.
One moment. And again, as a reminder to everyone, we're taking questions from the community. Here's the link again. I'll drop it in the chat to anyone that's still with us. Please feel free to ask any questions. This portion is for you. So let's start from the top. In your opinion, what is one technique in machine learning or deep learning that is underrated but very useful?
I'm not sure about. I'm not sure if there's one technique, and I'm not sure if it's underrated. I think generally following Jeremy's advice is always useful, but I think people recognize that in general. I think one of the things that I found in this competition that worked really well for me is this data recipe, where you where you try to control the order in which you put data into your training group, and you're very deliberate about it. So you don't reset your optimizer. You train for let's say for one epoch, but then you put data at a certain sequence. I have not, and maybe somebody has done it before. I have not seen that personally, but yeah, I think data is like the way you use data and external data is often super helpful.
Interesting. Maybe your ablation studies will tell us more about that. If you try those experiments.
Hopefully.
So this is Mani. I'm sure you recognize him. And I personally also, I'm really curious about this. How do you manage everything with life, and how do you overcome the challenges that you might face with family responsibilities, the leadership role, and Kaggle?
Yeah, that's a tough one. I don't think there's a good answer to it. Like my answer is like I'm taking a break now from Kaggle because I cannot be in this mode of competing, especially like with like competing seriously. And maybe like also time boxing a competition. So with Chai, I think what worked really well for me is I didn't put the same effort throughout the whole competition, which was 3 months. But I really focused for a month out of the 3 months at the very end, and I sacrificed, I would say, primarily sleep during that time, and obviously like this had implications because like the level the amount of attention or energy I could put in other places was lower. I tried not to reduce my attention to family or to my job, but for sure the fact that I sleep fewer hours had an implication. So you cannot do that on a longer basis. So I try to take a break now, get some more sleep, spend more time with family, like focus on my job, and then at some point, like maybe dive into another competition. But like you need to be careful. Like Kaggle can get so addictive that unless you stop yourself, like I'm seeing these new competitions that are coming and they are so interesting, and I'm trying to keep myself from jumping in because I know I should not do that. I need to do other stuff first.
That's
I don't know
very.
if this is a good answer, but it's.
I think that's a very honest answer.
Yeah.
So I think I wasn't active in the competition, but from what I understand, this was discussed in the forums. Maybe you could correct me. How did you decide to use external data, and what was the logic behind this?
Yeah, I think this is probably how do I know that external data was required? I think that was like the fact that we had very little training data. That meant that the obvious way to improve your performance was to just get more data. And I think the host was very explicit about it, that they are looking for the competitors to come up with new data sets and potentially create them. I think the idea was to kind of collectively improve the state of the Indic languages NLP by creating more data sets. At the end, it turned out that you can actually get pretty far by using external data from other languages, from similar language families. So I'm not sure if that was anticipated by the host, but that's what turned out to be really helpful here.
Makes sense. I'll skip this one since we've discussed it. This is interesting. Are you thinking of any data sets for the application studies you mentioned, or have you thought about it at all?
Yeah, that's a very good question. I don't have an answer to that yet. So Mani, if you have any ideas, I'm super open. I posted this on the Discord servers in FastAI and Hugging Face. I'm looking for people with ideas on how to test it. I'm not really a researcher, so I need to figure out how to do it properly. But if somebody knows how to do it, I'm super open and welcome. Like advice is welcome.
Maybe someone could start a thread on our forums and we could figure out a way. But again, that's for the audience to decide. I'm really probably the biggest noob in this chat right now to even comment on that. Question around the Ensemble. So did you end up using all of the models, or if you could just clarify on that?
Yeah. Yeah, so so the sample was consisted of 13 models, and they were divided into 3 subgroups, and they like each of them had a different training scheme. So there was variation. So sometimes like there was definitely randomness. I'm not necessarily different data sets, because sometimes I trained with the same data sets, but I would put them in different order, or I would apply different augmentation. There was some randomness with this negative sampling, and so each of them had variation on the data, but sometimes the data sets were the same.
Okay. Thanks for that clarification. I'll give anyone another minute to ask any questions. I see someone is typing. In the meantime, since we're almost on the top of the hour, I'd love to point everyone to Darek's profile on Kaggle. If you go there, it's simple to find him. He said he didn't think of his username. I think it's a very interesting username. His username is the Dr. Cat. I know a Dr. HP who
and I'm
is
not a
also
doctor for sure, so I'm more of a cat than a doctor, to be honest.
But I wanted to say I know a Dr. HP who's also from the FastAI community, also doing amazing on Kaggle. So just wanted to point that out. If you go to his profile, you should be able to find his Twitter profile from there. His handle is DK21. Please make sure you find him on Twitter. And he also has amazing blog posts. There are a few. I hope to see more here, Darek, if you find the time. I don't know how you find the time even for this, but the website is skok.ai. So I would highly encourage everyone to check the blog out. Okay, maybe they didn't ask the question. All right. With that, as a reminder to everyone who might be watching the recording later on or who's live, if you want to find these links, I'll post these on our forums after the conversation. Thanks again, everyone, for joining us. And thank you so much again, Darek, for sharing your journey and sharing your, I would say, very beautiful solution with us. I'm sure the audience learned a lot today.
Thank you. It's a great honor to have people listening to what I have to say. So I appreciate everyone listening live or listening later on YouTube. And thanks a lot, Sanyam, for being such a great host. Like you make it real fun to be having these discussions. Appreciate it.
I just drink chai and ask stupid questions. That's all I do. But awesome. I'll wrap up here. Thanks everyone for joining. Hope you have a great weekend ahead. As a reminder to anyone who's watching this, we have the Chaii study group happening tomorrow. I won't waste Darek's time by talking too much about that, but the long story short version, if you want to learn about Chaii, we'll be starting a study course tomorrow. Please make sure you join that. You can find more details on our forums. Awesome. I'll end the live stream here. Thanks everyone.